Hello and welcome back. So we're now going to move over to chapter 2 and we can see our spec runner here. And we're going to click on the first of the descriptions and that's going to make sure we're only running these 5 tests. When we go to Atom, we'll be inside chapter 2 spec and function.js. Now the first thing we have going on here is a clone object method. Don't worry too much about it, but it's basically going to demonstrate how passing by reference versus passing by value works. So we're going to head up our debugger after our first it statement, and then we're going to run through the code and see how it all works. So to make sure that works, we're going to open up our inspector, make sure our sources are open, and we're going to reload it. And we're going to make sure we save first, and we're going to reload it. So the very first thing we do is to define a function as we've seen before. We use the var keyword. We state what the function is going to be, and then we give it the parameters. I'll have this in the miscellaneous section for this chapter, but these are what are known as parameters. That's the variable names you give in the function definition. And the function definition is this part right here. The arguments are the actual values that you pass in to the function. So here we're going to expect that whenever we add the function, 1 and 2 is our parameters, and we return them, we're going to get 3. And if we want to run that down here, we have access to add function, so we can run it for ourselves, and we'll see sure enough that is the correct answer. And remember, if we want to jump into the internals of that, we can use the step into function right here, and that's going to show here we have 1, here we have 2, corresponding to 1 and 2 separated by the commas right here. And then we're going to typecast them to a number just to make sure that we can actually add them correctly so that it doesn't pass string 1 and string 2, which would give us 12 instead of 3 as we want. Next, we're going to go to the next section. So here we have closures, and you're already seeing a closure right here. Because this variable definition occurs within this function, everything that is part of this function has access to the clone object. So right here we have a equals 1, and then we're going to return that. So here in our add function, we're only giving it the number b, and then we're going to return a and b. And you can see here, even though I'm not passing it as a parameter, it still knows what the value is. So to show that, we'll call our add function again, since this time we only have one argument, and we can see that calling it gives us 4 because the a is still held in memory and reference from this outer closure. Now it's important to note that most programmers will tell you that this sort of thing is a bad idea, and that's because of what are known as pure functions. In math, a pure function should always return the same result if the same arguments are given to it. Well here, because we have this outer scope variable that's being used in the inner scope, if we change the value of a to something besides 1, then whenever we run the add function, we're going to get a different result. So if we say a equals 2, and then we try our add function again, now instead of getting 4, we have 5, even though the exact same arguments were used. So this is considered to be a bad practice. But there are many times where you do need access to something in the outer scope, as the example right here. We need access to clone object outside of where we're going to be using it. So next, we're going to actually take a look at what that means. So there are 2 ways to pass variables around. One is to pass them by reference, and the other is to pass them by value. Generally, you pass things by value, and that means that whenever I pass in 2 right here, if I was to pass that in as a variable, it would create a copy of 2 right here, and if I changed the value outside somewhere else, it would not change it inside this function right here. However, when you pass by reference, any changes made to one object will be carried over to the other one, or to one variable, they will be carried over to the other variable. So here I have a function named a, and you can see here that it still thinks a is equal to 2 because it's running right here. So I'm going to jump out of there. So here I have my function, which I'm just calling a, which is a terrible name, but this is just for demonstration purposes. This is going to return an object. Now I haven't touched on it before, but you'll notice that I don't have a semicolon right here. JavaScript uses something called ASI, automatic semicolon insertion, and that means that if it thinks there should be a semicolon somewhere and it can't find one, it's going to insert one. Usually it does this on line breaks. That's the reason why you see the return being written like this, not like this. If you write return like this, what JavaScript will do internally is add a semicolon right there, and that's going to cause your code to fail because it's going to return undefined, whereas we want it to actually return an object back to us, and an object with the first name of Bob. So a.firstname should give me Bob. So now as I run over my code here, you can see here that I said b is equal to a, and I'm invoking the function. So now I have a b object with the first name of Bob. I'm setting c equal to b, and then I'm setting d equal to c. Now I'm going to change the first name of b. Now when you pass objects by reference, here's the key point. Notice on all of these objects that as soon as I set b equal to Bob, all of them changed as well. That's what copy by reference does. Everything is pointing to one object in memory. So as soon as you change the value on that object, all other objects pointing to it now have their values changed. So now everything is equal to Bill, just as we saw there, and everything is going to be Bill. And this is a pretty big problem if you're not expecting it to happen. Changing the value of one object will change everything else. In order to avoid that, we're just going to invoke a 3 times, which is going to keep jumping me up to where I have my breakpoint set up. Now we have 3 separate objects instead of three variables that point to one object. And now whenever I change b's first name, everything else still maintains the original values that were given. So that's one way to avoid having this sort of variable collision, is to simply invoke the function each time rather than invoking it once and pointing everything to that one object. You will get unexpected results. Next, I'm going to use a person constructor, which is just going to set the value of first name and last name equal to whatever gets passed in there. So my first new person is going to be Bob, and Bob's going to have a name of Bob.doe, and Bill is going to be pointing to Bob. So these two things right now are the exact same thing. So when I run it, they both have the same values inside of them. And when I run 2b, which is asking this question, it's saying, is Bill equal to Bob? And the triple equals means both the same value and the same type, and this is returning true. Now, if I want to break that link, I'm going to run the clone object function, and that's going to take the values and then change them from pass by reference to pass by value. So my first test says I expect Bill not to equal Bob. So that's going to be this statement here. And that is now true after cloning the object. Now I'm going to set the first name equal to something different. So Bill's.firstName is going to be equal to Bob, and Bill.last name is going to be equal to Doe. Excuse me, I'm not setting it yet, but I am showing they both have the same values inside of them. So Bill.firstName equals Bob.firstName. And that's a true statement. Now to prove that's a true statement, I'm going to set Bob's first name equal to Bobby, and it's going to make sure that now you see the link is broken. When I changed one, it didn't change the other one, unlike what happened up here where changing one also changed the other one. And just to demonstrate how primitive values are assigned, here I'm going to use the string John for var a, and then I'm going to set b equal to a. Now I'm going to set b equal to Bill, and you'll notice that this time b and a did not copy by reference. They're two separate things. So when you're dealing with primitives, you don't have to worry about this, but when you're dealing with objects, if you set one equal to the other, it's going to pass them by reference. Again, that's kind of advanced JavaScript, but it's important to understand that because you can get some bugs if you don't understand how that works. Next, we're going to look at creating private variables. A private variable or a private method is whenever a variable cannot be seen outside of its scope. So inside the person scope, I will be able to see first name and last name. But if I attempt to change them, it won't do anything. I have to go through the getters and setters. Now, you'll see this return this, and that's just using what's called method chaining or fluent modeling. and it's just a nice syntactic sugar to be able to chain together multiple setters. You also see this right here. That means if I create a person but I don't use the new keyword, it's going to go ahead and automatically create it for me. So I'll automatically get a new constructor out of this. It's a nice way to protect users. So now I'm going to step over it. You can see here that I'm going to create a new person called Bob using the new keyword, and then I'm going to create a Jane as a person. And they're both going to have the exact same getters and setters inside of them. Notice though that the first name and the last name are not accessible. Those are hidden right inside of here. They're private. So now I'm going to set Bob's first name using the setter right here. And then I'm going to try to set it directly. That means I'm going to try to use the variable. And then I'm going to use the fluent setters for Jane, which is going to give her a last name of Doe and a first name of Jane. So now when I call bob.getFirstName, notice that it's going to be equal to Bob. The Bill was completely ignored. And we can see that using the Jane.getFirstName or getLastName and first name, those have the same values that we used right here. So this is what's known as protecting your variables. So if you don't want someone to just be able to access variables directly, if you have some security features you want to implement, like making sure that before they can get the first name, it's not a number, that it's a valid string or whatever, then this is how you go about doing it. So that's a brief look at functions. Functions are generally considered one of the things JavaScript got right. So there is a lot to cover in in functions, but that would be saved for a more advanced topic dealing with all the ins and outs, intricacies of how functions work in JavaScript.